Bismillahirrahmanirrahim. Hi everyone. I hope you are all doing well. I welcome you all in class of O-level mathematics. Uh, our discussion is continue on probability and combined events. At this topic, I have already delivered 11 lectures. In today lecture, inshallah, we will close this chapter. So this lecture might be a bit long. Inshallah, in this lecture, I will share most important repeated problems that you can see in your previous year questions. So some topics related to mutually exclusive and not mutually exclusive events, dependent and independent events, uh, we will share here. So I hope inshallah you will enjoy from this lecture. If you find this lecture helpful, kindly like, share and subscribe my channel. In the next lecture, inshallah I will share 2025-2024 last 5 year, at least last 5 year question papers related to probability and combined events. Although a separate playlist for year-wise past paper solution is also available at this channel. You can also watch this. Furthermore, if you do not want to do not want to see this lecture completely, I have made the chapter sections that you can find in the description box. So start from the topic that we will discuss in today's lecture. In today's lecture, I will discuss mutually and not mutually exclusive events, addition laws of probability, dependent and independent events, multiplication law of probability, and most repeated and expected problems of probability. So start from addition laws of probability for mutually and not mutually exclusive events. So firstly, we discuss what does mean by mutually and not mutually exclusive events. Two events A and B are called mutually exclusive events if they cannot occur together. If they cannot occur together, then two events A and B are called mutually exclusive events. For example, if A shows even number and B shows odd number on a single die, then A and B are mutually exclusive events. Because when you throw a single die, either it will be an even number or it will be an odd number. This is not possible that both of the number can occur together. So in this case, the occurrence of even and odd number shows mutually exclusive events. Similarly, if A shows head and B shows tail on a single toss of a coin, then A and B are mutually exclusive events. Because when you throw a single coin, this is not possible that both of head and tail occur together. Either one of the occurrence will be appeared, either it will be head or it will be a tail. If A shows card of king and B shows card of queen, then on a single draw of a card from a playing card, A and B shows mutually exclusive events because there is a no card in playing card that represent both queen and king. So they cannot occur together. That's why A and B are mutually exclusive events. If A shows that a person will alive for the next 10 years and B shows he will be die within next 10 years, then A and B are mutually exclusive events because either he will be alive or he will be die. This is not possible for a person that he alive and die at the same time. So these events are mutually exclusive events. On the other hand, two events that can occur together are called not mutually exclusive events, and in some books you can find inclusive events. Not mutually exclusive mean inclusive events. For example, if A shows prime number and B shows even number on a single die, then A and B are called not mutually exclusive events, because 2 is the single prime that is even as well as it is prime. So both of events can occur together. So that's why we can say that A and B are not mutually exclusive events. Similarly, if A shows card of king and B shows card of heart, then A and B are not mutually exclusive events, because both of possibilities can occur in the same card, because this is a card king card and it is also card of heart. So both events can occur at the same time. So this shows that A and B are not mutually exclusive events. Similarly, if A shows card of queen and B shows a picture card on a single draw from a well shuffled pack. Well shuffled pack means playing cards. Then A and B are not mutually exclusive events, because there are 12 picture cards uh, that include 4 coin, 4 king, and 4 jack. It means queen card are also picture card. So both of the events can occur at the same time. That's why they are not mutually exclusive events. Similarly, from a group of 100 students, if A shows the student of O level and B shows he read additional mathematics, then A and B are not mutually exclusive events, because this is possible that if a student is of O level, then he can read additional mathematics. So these are the mutually exclusive events. So I hope now you have a clear understanding about this topic, mutually and not mutually exclusive events. Next, we discuss addition law of probabilities, which are related to mutually and not mutually exclusive events. For a mutually exclusive events, the probability of A or B. This word or is logically denoted by union. So A or B mean A union B. If two events are mutually exclusive events, then probability of A union B is probability of A plus probability of B. Because they are mutually exclusive events, so they cannot occur together. It means their intersection will be empty set. And in case of empty set, the probability of empty set is always 0. So that's why this formula is equal to probability of A plus probability of B. For a not mutually exclusive events, probability of A union B is probability of A plus probability of B minus probability of A intersection B. Because at this time, your events are not mutually exclusive events, so they can share some common points. So that's why their intersection will be non-empty. So in this case, probability of A intersection B is possible. So let us discuss this concept with some important problems that you can see in your past papers. This is problem number 1, and this is a long problem. I have divided this problem into 12 to 13 parts. A card is drawn at a random from a standard pack of 52 playing cards. Find the probability that the card is an ace. Actually, this problem is related to the information of cards. If you have no sufficient information of card, inshallah, after watching this problem, you will be clear about the information of playing cards. Here, total cards, these are 52. Total ace. We have to find the probability of ace. Ace means a card of A. There are total 4 ace. We have to draw one card. So probability of an ace is 4 out of 52. This is 1 over 13. So probability of an ace is 1 over 13. Probability of a king. To find the probability of king, you have to find the total kings. Total king are 4 in a pack. So probability of a king is 4 out of 52. That is same 1 over 13. A red card. There are a total 26 red and 26 black card in playing cards. So half of the card are red and half of the card are black. So the probability of red card is 26 out of 52, that is 1 by 2, which is equal to 0.5, 50%. Next we have to find the probability of a black coin. Black coin. There are the two cards. Total four cards are of coin in a well shuffled pack. Two are of red and two of black. The two black coins are this is queen of spades and this is queen of black. These are the symbol of club and this is the spade. So there are the two and both of colors are black here. This is a black spade and black club. So there are two black coins. So probability of a black coin is 2 out of total 52. This is 1 over 26. An ace or a king. This is the probability of or. It means now you have to find the probability of union. So in this case you have to decide whether is there intersection between ace and king. Is there any card that represent both ace and king? Is it possible on a card that it is also a and k? Have you seen any card like this? This is not possible. There is no card that represent both of the qualities. It is also a card of ace and card of king. So this is these events are actually mutually exclusive events. They cannot occur together. So in this case, we will just use the formula probability of A union B is equal to probability of A plus probability of B here. So it means here probability of ace or a king is simply probability of ace plus probability of king. How many ace are in a pack? There are total 4 ace out of 52. Similarly, there are 4 kings out of 52. So 4 over 52, 4 over 52, this is 8 over 52. And after cancellation with the 4, 4 2s are 8, 4 13s are 52, this is 2 over 13. Neither an ace nor a king. Here we will use a law of complement of a probability. As here probability of an ace or a king, we have to find neither an ace nor a king. Means this is equal to simply probability of a complement is 1 minus probability of a. So probability of ace or a king is 2 over 13. So neither an ace nor a king is given by 1 minus 2 over 13. This is 11 over 13 here. Next we have to find the probability of a spade. There are 13 spades in a card. Actually, if you have no information about playing cards, you can see my previous lecture. In that lecture, I have delivered the information of playing cards. From that lecture, you can see how many spades, clubs, and every information you can see from that lecture. Probability of spade. There are total 13 spades and we have to draw a spade. It means we have to draw a card. There are total 52 cards. This is 13 over 52. That is 1 by 4. Probability of an ace or a spade. Again, this is or. It means we have to find the probability of union. Let A represent ace and B represent spades. Here A and B are not mutually exclusive events. It means they can occur together because there exists a card of ace which is also card of spade. In playing card, you can see there exists a card. This is a card of ace, and this is card, and it is also card of spade. Like this. So it means intersection is possible. So there exists a card of ace which is also a card of space. Probability of ace. Total four. There are total four A's out of 52. Total spades are 13 out of 52. And A intersection B. This is one of the card, which is card of ace as well as card of spade. So intersection in the probability of intersection is 1 over 52. So probability of A union B is probability of A plus probability of B minus probability of A intersection B is given by 4 over 52 plus 13 over 52 minus 1 over 52. This is 16 over 52. That is after cancellation 4 over 13. A picture card. Total picture card are 12, which are given by 4 kings, 4 queen, 4 jack. So these are 12 cards. We have to find a picture card. So this is simply given by 12 out of 52. That is 3 over 13. Neither a 7 nor a picture card. Firstly, here we have to find the probability of complement actually. Firstly, we find a probability of a 7 or a picture card. There is a word or. Again, we will use probability of union. Probability of card is a 7. There are total 4 cards of 7. One is card of spade, one is card of club, one is card of heart. So there are total 4 cards. This is 4 over 52. After cancellation, this is 1 over 13. Picture card. Total picture card. Probability of picture card we have already found. This is 3 over 13. This is 3 over 13. So probability of a 7 or a picture card. These are the mutually exclusive events because there is a no card which is card of 7 as well as card of picture. So this is probability of card of 7. This is plus probability of picture card. Card is a 7. This is 1 over 13. Probability of a picture card. This is 3 over 13. Their sum is 4 over 13. Next, we have to find the probability of neither a 7 nor a picture card by using the law of complement. This is simply given by 1 minus 4 over 13, which is equal to 9 over 13 here. A 7 or a diamond card. Again, this is or. We will use concept of probability of union, but we have to see here whether here we will use probability of mutually or not mutually exclusive events. Given events are not mutually exclusive events because there is a card in common which is a card of 7 and represent also a diamond card. And this is your card that represents this is a card of 7 and it's also card of diamond. That A represents this is a card of 7. So its probability is 4 over 52 because there are 4 cards of 7 out of 52. So probability is 4 over 52. Let B represent card of diamond. So probability of B is 13 over 52. In their intersection there is only one card. So probability is 1 over 52 here. So probability of a 7 or a diamond card is given by probability of a card is 7, probability of a diamond card or probability of both. That is probability of A plus probability of B minus probability of A intersection B. Probability of A is 4 over 12 for 52. Probability of B is 13 over 52 minus probability of intersection is 1 over 52. After simplification, this gives 16 over 52, that is 4 over 13 here. A coin or a card bearing a prime number. Again, this is a or. So you have to see here whether these events are mutually exclusive or not mutually exclusive events. Probability of a coin card are 4, so their probability is simply 4 over 52. Next, total card bearing a prime numbers. Their prime number mean the first prime number is 2, second is 3, third is 5, and fourth one is 7. These are the possible prime number on playing cards. Each card is repeated 4 times. So 4 cards of 2, 4 cards of 3, 4 cards of 5, 4 cards of 7. It means there are total 16 cards that bearing a prime number. So probability of a card bearing a prime number is 16 out of 52. Hence, a coin or a bearing a card bearing a prime number. Actually, these two events are also mutually exclusive events, because on a coin card there is a no number. Mean to say, you cannot say that the card of coin is yeah, or card of king is 11, card of coin is 12. There is no counting on the these picture card. So these are the mutually exclusive events. Probability of a coin is 4 over 52. Probability of card bearing a prime number, this is 16 over 52. That gives, after simplification, 20 over 52. That is equal to 5 over 13. A card bearing a number that is divisible by 2 or 3. Again, this is OR. It means we are interested to find the probability of union of two events. Given events are not mutually exclusive events, because there are 4 cards of 6 which are divisible by 2 and 3. These two events are not mutually exclusive events. First event is card is divisible by 2. Second event is card is divisible by 3. In the well shuffled pack or playing card, there is a card of 6. As 6 is divisible by 2 and 3 both, it means their intersection is possible. And total, there are 4 cards of 6. One card of spade, one card of club, one card of heart, and one card of diamond. So there are total 4 cards. It means their intersection is possible. For our convenience, just I say A represent a card of bearing a number that is divisible by 2. B, a card bearing a number that represent bearing a number that is divisible by 3. So probability of A is, A mean a card divisible by 2. There are total so a number divisible by 2 in playing cards are 2, 4, 6, 8, 10. These are the 5 number in playing cards that are divisible by 2, and each card is repeated by 4 times. It means there are total 20 cards. There are 4 card of 2, 4 card of 4, 4 card of 6, 4 card of 8, 4 card of 11, 10. So these are the 20 cards. That's why I have written here 5 into 4. So this gives 20 over 52. Similarly, probability of B. B means a card divisible by 3. The number divisible by 3 in playing cards are 6. The first is 3, second is 6, and third one is 9. Each number is repeated 4 times. It means this is 3 into 4, 12. Last one. Their intersection. Intersection mean a number divisible by 6. There is only one number that is divisible by 6. It is itself. As there are 4 cards of 6 in playing cards, so its probability is 4 over 52. Probability of A union B is probability of A plus probability of B minus probability of their intersection. This is 20 over 52, this is 12 over 52, this is minus 4 over 52. After taking its LCM, this gives 28 over 52. And after cancelling with 4, this is 4 into 7, 28, this is 7 over 13. So it ends problem number 1. Next, we move to problem number 2. This is also very interesting problem. This problem says 11 card numbers 11, 12, 13, 14 up to some 21. These are not the playing cards in a standard sense. These are 11 cards number 11, 12 up to some 21 are placed in a box. A card is removed at a random from the box. Find the probability that the number on the card is even. This is very simple. Total cards having even numbers from 11 to 21. The first even number is 12, second is 14, third is 16, 18, 21, 20. Total these are 5 even numbers. So probability of a card of even number is 5 over 11. Total numbers from 11 to 21 are 11. This can be obtained by subtracting 11 from 21 plus 1. 21 minus 11, this is 10. 10 plus 1, this is 11. Uh, Further, you can otherwise you can count this number from 11 to 21. This will be 11. So this is the probability 5 over 11. Probability of prime number. Prime number from 11 to 21 are, the first prime number is 11, second is 13, third is 17, and fourth one is 19. So total prime numbers are 4. So probability of a card of prime number is 4 over 11. Either even or prime, that E shows even number and P shows prime number. Then we have already found the probability of even number. This is 5 over 11, and this was the probability of prime number 4 over 11. So probability of even number is 5 over 11, probability of prime number is 4 over 11. In this range from 11 to 21, there is a no prime number which is also even. You know, there is only one prime number that is even. This is 2, and 2 is not in this range. So it means there will be no intersection. E intersection P is empty set. So we will use probability of E union P by mutually exclusive events formula. This is probability of E plus probability of P, which is 5 over 11 plus 4 over 11. That is 9 over 11. Neither even nor prime. This is simply by using law of complement. We can subtract the probability of even or a prime number, that is 9 over 11, from 1. This is 2 over 11. Here we have find probability of either even or prime. This is 9 over 11. So after subtracting 9 over 11 from 1, this gives 2 over 11. Problem number 3, this is also very important. Welcome back. Dear students, if you want to get these notes, these PDF notes, or if you are interested for personal tutoring, you can message me or contact me at this number 0315-164-8755. This is my personal number. WhatsApp is also available at this number. So let us start our discussion. This is problem number 3. This problem is also very interesting, and this type of problem you can also see in your past papers. Problem says a bag contains 7 red marbles and 5 green and 3 blue marbles. A marble is selected at a random from the bag. Find the probability. This is a red marble. For this type of problem, firstly we mention which type of marbles or ball are given. These are R mean red marble, G mean green, and B mean blue. So there are 7 marbles, red 7 marbles, and there are 5 green marbles, and these are 3. Total are 15. We have to find probability of red marble. Red marble is 7, and the selected marble is only 1. So this is given by 7 over 15. Next we have to choose a green marble. Total green marble are 5 out of 15. This is 5 over 15. This is 1 by 3. Next we have to find probability of either a red or a green marble. This is or mean union. So we have to find probability of R union G. These events are actually mutually exclusive events because there is no marble of the both color. In the question you can read that there is no information given that some of the marbles having red and green both colors. So these are the mutually exclusive events. So R union G, probability of R union G is simply given by probability of R plus probability of G. Probability of R is 7 by 15 and probability of G is 5 over 15 that we have calculated here. So this becomes 12 over 15. That is 4 over 5 after cancellation. Neither red nor a green marble. So for this we will use law of complement. Neither red nor a green marble mean this is the complement of R union G, which is equal to 1 minus probability of R union G. Probability of R union G is we have calculated 4 over 5. So this become 1 over 5. Alternatively, you can find it as when you say when it is neither a red nor a green marble, then it is a blue marble. So, so a blue marble, there are total blue 3 out of 15, 3 over 15, this is equal to 1 over 5, that is the same as. Next question is problem number 4. The letter of the word mutually and the word exclusive are written on individual cards. And the card are then put into a box. A card is picked at a random. What is the probability that the letter on the card is U? Uh, we have made different cards for each letter. Like for mutually, there this is one card of M. For U, there is second card mutually. There is a third card of T. So this is the sequence. So now he says, what is the probability that the letter on the card is U? Total letter in mutually exclusive. In these two words, total letters are 17. You can count here. In these two words, U repeats 3 times. This is U, and this is also U. So there are 3 times U. So this becomes probability of RU is given by 3 over 17. And E repeats 2 times. You can see here in these words. First E is here exclusive, and the second one is E. So there are 2 E here. So E repeats 2 times, so probability of NE is 2 over 17 here. Probability of RU or NE, or mean union. So this is given by the addition. Probability of RU plus NE, these are the mutually exclusive events, because this is not possible that at the same time we have a letter which is also U and E. So intersection is not possible. Probability of a U is 3 over 17, and probability of an E we have calculated 2 over 17. Their sum is 5 over 17 here. A consonant. Total consonant in mutually exclusive are 10. Letter other than vowels are called consonants. So the first consonant is M, second is T, third is L, again L, 4, 5, 6, 7, 8, 9, and 10. So there are 10 consonants. Probability of a consonant is 10 out of 17 here. Probability of a U or a consonant. Events are mutually exclusive because U is a vowel and so this cannot be a vowel consonant. So events are mutually exclusive. So probability of a U is 3 over 17, and probability of consonant we have calculated 10 over 17. So probability of a U or a consonant is given by their sum 3 over 17 plus 10 over 17, that is 13 over 17. Probability of a U or vowel. Given events are not mutually exclusive because U is also vowel. Probability of U is 3 over 17, probability of vowel are 7 over 17. From the words mutually exclusive, you can count the vowels. First vowel is U, again is U, third is A, fourth one is E, sixth one is U, seventh one is I, eighth one is E. I think these are 8. These are 8. First one U, A, E, U, I, E. These are 4 and these are 3. 7. These are 7. 7. Yes. So probability of a vowel is 7 over 17. So probability of a U or a vowel. This is given by probability of U, probability of a vowel, probability of A, probability of a U and vowel. So probability of U is 3 over 17, probability of vowel is 7 over 17. Now you have to count the letter here, which are U and vowel. In other words, you have to count how many times U repeat here. So this is U 2 time, and this U is 3 time. So there are 3 U. So this becomes cancel, and final answer is 7 over 17. So it completes. So in the, with these problems, 4 problems, I have completed the concept of addition law of probabilities in a fully detailed version. I hope now you have a clear understanding of mutually and not mutually exclusive events and addition law of probabilities. Next, we move towards the second topic of this chapter, that is the concept of dependent and independent events and the multiplication law of probability. I hope now you are enjoying from this lecture. If you are enjoying, if you think this lecture is helpful, please like, share, and subscribe my channel. This will be a very great help for me from your side. Calculating probability of combined events. Uh, sorry. This topic is continued still here. Now in this topic, I am going to calculate the probability of combined event when sample space is not given. Sometimes it is possible that we cannot make the sample space. This is problem number 5. Probability of 3 teams L, M, and N winning a football competition are 1 by 4, 1 by 8, and 1 by 10, respectively. That is, team L can win the competition. Its probability is 1 by 4. Team M can win the competition. This is probability. It has the probability 1 by 8, and the last one has the probability 1 by 10. Only one team can win the competition. So intersection is not possible here. Explain why more than 3 teams in the competition are possible. This is our first question. Since it is given that only one team can win the match, the events of each of the team L, M, and N winning are mutually exclusive. It means they cannot. It means 2 or more than 2 teams cannot win the match at the same time. Next, probability of L wins, probability of M wins, probability of N wins. The sum of probabilities is 1 by 4 plus 1 by 8 plus 1 by 9, 1 by 10. This gives 19 over 14, which is less than 1, clearly. As we know, total probability is equal to 1. It means there is a space. Therefore, there are more than 3 teams in the competition, because total probability should be equal to 1, and the sum of these three probabilities is less than 1. It means there is a space of other team also in this competition to complete the sum equal to 1. Next is either L or M win. This is or, it means we will find the probability in case of union, because it is given that both team cannot win, so the events are mutually exclusive. So this is simply probability of L wins, probability of M wins. What is the probability of L wins? It is given, this is 1 by 4, and probability of M wins, this is 1 by 8. Final is 3 by 8. L does not win. This is simply law of complement. This is equal to 1 minus probability of L wins. 1 minus 1 by 4. This is 3 by 4. Neither L nor N wins. Same type of question we have already done. Firstly, we find the probability of either L or N wins. Probability of L or N wins, probability of L wins plus probability of N wins. This is 1 by 4 plus 1 by 10. This is 7 over 20. Now to find the neither L nor N. Neither L nor N mean this is actually probability of L union N whole complement. So this is equal to 1 minus probability of L or N wins. Probability of L union N whole complement, this is equal to 1 minus probability of L union N. In other words, this is probability of L or N. That is 1 minus 7 over 20. This is 13 over 20. This is very important. This is a conceptual question. This question says, is probability of neither N nor N win equal to probability of L does not win plus probability of N does not win? In other words, this question wants to ask, uh, does it mean probability of neither L nor N wins mean this is the sum of two probabilities, that L does not win, N does not win. Actually, this statement is not true in general, because we have a result when we say probability of neither A nor B. It means probability of A union B whole complement, and this is equal to simply 1 minus probability of A union B by law of complement. If and on the other side, this can also be written as, by using the law of De Morgan law, you know, this A union B complement is equal to probability of A complement intersection B complement. So these three expressions are equal. On the other hand, what's about the right hand side? Probability of node A, node B. Probability of node A, node B mean simply probability of node A mean probability of A complement, node B mean probability of B complement. On the left hand side, this was probability of A complement intersection B complement, and the right hand side is probability of A complement plus probability of B complement. This cannot be equal in any case. Only if their probability of their intersection is 0. Further, from the given question, we can justify left and right hand side. Here we have calculated probability of neither L nor N win. This is the probability 13 over 20. This is the answer of left hand side. This is the answer of left hand side. So this is our left hand side. And if we find right hand side, that is probability of L does not win plus probability of N does not win. L does not win has a probability 3 over 4. N does not win has a probability 9 over 10. This can be simply calculated as probability of L win 1 by 4, so its complement is 3 by 4. Probability of N win is has a probability 1 by 10, so its complement is 9 by 10. So by adding these two probabilities, we have 33 by 20, which is greater than 1, and this is not possible. And we can see left hand side and right hand side are also not equal. So this shows these two expressions are not equal. So we cannot say probability of neither L nor N means probability of L does not win plus probability of N does not win. This simply means 1 minus probability of either A or B win. Next. This is problem number 6. This is also very interesting problem. The probabilities of a 4 team E, F, G and H winning a hockey competition 1 by 3, 1 by 5, 1 by 7, 1 by 11 respectively. Only one team can win the competition. It means these are the mutually exclusive events, because this is not possible that two or more team can win the match. Calculate the probability that either E or F win. E or F mean either E win or F win. Probability of E win is 1 by 3, probability of F win, this is 1 by 5, and finally is 8 by 15. F, G or H win. Probability of F, G or H mean probability of F win plus probability of G win plus probability of H win. Actually, this is the probability of F union G union H. So from this result you can see we can use addition law of probability for more than two sets. So this is simply probability of F plus probability of G plus probability of H when the events are mutually exclusive, mean to say there is no intersection between any two sets. Their intersection is empty set. So this is simply equal to probability of F plus probability of G plus probability of H. So by adding 1 over 5, 1 over 7, 1 over 11, this gives 167 over 385. F doesn't win. This is simply given by law of complement. This is equal to 1 minus probability of F win. Probability of F win is 1 over 5. This is equal to 1 4 over 5. F, G and H do not win. None of the team win here. So at the same time, this is simply equal to 1 minus probability of, I will use the law of complement here. When you say probability of F, G and H do not win, it means this is equal to 1 minus probability of either F, G or H win. Either one of them win. So either one of them win is probability. This probability either F, G or H win. This probability we have calculated here 167 over 385. So this is equal to 1 minus 167, 285. This is 218 over 385 here. Next now we are going to discuss the important topic of this chapter. This is multiplication law of probability for dependent and independent events. Now we will start. We will start our discussion from the definition dependent and independent events. Two events A and B are called independent events if the occurrence of event A does not affect the probability of occurrence of event B. It means the occurrence of event A does not affect the probability of occurrence of event B. Mean A and B have no relation. They are independent from each other. Otherwise, they are called dependent event. And if the occurrence of event A affect the occurrence of event B, it means they are dependent event. We elaborate this concept by using simple example. For example, if A represent the drawing of an ace from a pack of 52 cards and B is throwing a total of 7 with 2 dice, A is linked with pack of card and B is linked with 2 dice, clearly they are independent. There is no relation between these two events. So then events of A and B are independent. When you draw a card from playing cards, and on the other hand, when you throw a 2 dice, there will be no relation between, there will be no effect of occurrence of event A on the occurrence of event B. Suppose you pick a card from playing card and this is king card. Now can you say when on the other hand when you throw a 2 dice, it will not a 7 total, the total will not a 7. This is possible, total will be 7. So the occurrence of event A does not affect the occurrence of event B. So these two events are independent here. On the other hand, if A represent the ace on the first draw and B represent an ace on the second draw without including the first ace in a pack, then A and B are dependent events. This is important. I said that suppose you pick a card from the playing card and this is ace. So probability of ace at the first draw is 4 over 52. Now you do not replace the first ace card. Suppose this is a card of heart. Suppose you do not replace this card again to the playing cards and you pick again a second card from the playing. Now remaining playing cards are 51 and remaining ace are 3. So it means at this time this probability affects the probability of B. These are not same. It means these are the dependent events. Laws of multiplication If A and B are independent events, then probability of A and mean intersection or mean union. You will always remember that when we have a word and, it is linked with intersection. For or, we will use union. So probability of A and B, this is probability of A and B. In case of independent event, this intersection can be break to product. So probability of A intersection B is simply probability of A into probability of B. But in case if events are dependent events, then remember that probability of A intersection B never equal to probability of A into probability of B. Further, in case of independent events, we have to calculate. Suppose we have to calculate probability of A or B. That is probability of A union B. Its formula is probability of A plus probability of B minus probability of A intersection B. Because events are independent, so intersection can be calculated by their product here. Next problems are related to dependent and independent events, and these problems are nearly close to your past paper questions. Problem number 7, there are 7 green marbles and 3 yellow marbles in a bag. The marbles are identical except their colors. Mean to say they are physically same, only the difference is of their color. A marble is drawn at a random from the bag and is replaced in the bag. A marble is drawn at a random and look the color and is replaced in the bag. It means these are independent events. When we say we have replaced the ball in a bag, it means the second time number of balls will be same as the first draw. A second ball is then drawn at random from the bag. Find the probability that the first marble drawn is yellow. Let G represent green marble and Y represent yellow marble. So here total G are 7 and total yellow marble are 3, total are 10. Probability of green marble will become 7 over 10, total probability of yellow marble will become 3 over 10. We have to draw a marble. What is the probability that first marble is yellow? This is simply given by 3 over 10. This is interesting. This part is interesting. Make tree diagram in both cases with and without replacement for both drawn. Also represent probability at tree diagram. This is my first draw. When you when you pick a marble from the bag, this is your bag, and this bag have either green or yellow marble. So when you pick a marble from this bag, either it will be green or it will be yellow. So at the first draw, you have only two possibilities. Either it will be green or it will be yellow. The probability of green marble is 7 by 10 and probability of yellow marble is 3 by 10. Because green marble are 7 and yellow marble are 3 here. Now at the second draw, you have again two possibilities. Either it will be green or it will be yellow. This is the case of with replacement. With replacement mean you pick a marble, suppose this was green. Now again you put this green marble into the bag. It means now again your bag has a total 10 marbles. So it will not affect the probability at second draw also. So in the second draw, again you have 7 green marbles. These are 7. These are 3 marbles. So probability of green at second draw is 7 by 10. Again this bag has a 3 yellow marbles. So again probability of yellow marble is 3 by 10. Other possibility, when first marble was yellow, again in the second term when you pick a marble from the bag, you have two possibilities. Either it will be green or it will be yellow. Because this is case of with replacement and we have already replaced the yellow marble into the bag. So again yellow marbles are 3 and total marbles are 10 here. so it will not affect the probability. So it means green marble will have a probability 7 by 10 and yellow marble are 3 by 10. From this tree diagram you can notice that in case of with replacement, at each draw total probability, each draw probability of each marble will be same. This is an important note. In case of with replacement, in case of with replacement, w dot r mean with replacement. In case of with replacement, probability 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 will not change, will not change at any draw. Either you draw 2 times, 3 times, 4 times, probability will be same for each possible outcome. But in case when your case is without replacement, again I make a bag here. This is my bag that has green and yellow marble. There are 7 green and 3 yellow marble. Total are 10 marble. And this is my first draw. When at first draw you pick a marble, it will be either green or it will be yellow. There are total 7 green out of 10, so probability of green is 7 by 10. Similarly, there are a total 3 yellow marble, so probability is 3 by 10 here. So it finished the first draw. Now I have second draw. This is my second draw. In the second draw, when you have picked one of the green marble, now total greens left are 6, but yellow are still 3. But total marbles are 9 here. Now in case green, probability is 6 by 9. Because the first draw was green marble, so it will not affect the probability of yellow. It will not affect the total number of yellow. Total number of yellow ball again are 3 here, out of 9. So this is the 3 by 9. Probability of yellow in the second draw will be 3 by 9. In the second branch, when your first draw is yellow, now your green balls are 7, but your yellow marbles are 2. Total marbles are 9. Now what is the probability of green marble? This is the 7 out of 9. So this is 7 by 9. And now we have left over 2 yellow marble. So these are 2 out of 9 here. So in this case, when case is of without replacement, you can notice that it affects the probability. It affects the probability at each draw. Okay. So this completes the concept of tree diagram. Now from this tree diagram, we have to find the following probabilities. Okay, this part is very important. This says we have to find the probability that the second marble drawn is yellow, given that the first marble drawn is green, in case of with and without replacement. The second marble is yellow, given that the first marble should always be green. So here we will use our tree diagram. Second marble should be yellow. So yellow, we can reach to yellow from this branch, from green then to yellow. So this is the case of with replacement. First is green and second is yellow. So we will reach from green to yellow. We cannot use this branch because it is given, the condition is that first should be green. Again, you can read the question. We have to find the probability that second marble drawn is yellow, given that the first marble drawn is green. So that's why we are strictly follow this branch. We cannot use this branch. So this is 3 by 9 simply. The probability is 3 by 9 in case of without replacement. This is 1 by 3 here. And in case of with replacement, this is the tree diagram for with replacement. This probability is 3 by 10. So tree diagram, from tree diagram we can find easily the probability. The fourth one, this probability, this question says the first marble drawn is green, and this is the difference of part 3 from part number 4. The first marble drawn is green and mean intersection, and the second marble drawn is yellow in both cases. Firstly, we discuss the case of with replacement. Here we have to find the probability of gy. Gy means g intersection y here. This is simply probability of g into probability of y, because these are the independent events. In case of with replacement, gy, green and yellow. In case of with replacement, what is the probability of green? This is 7 by 10, and then probability of yellow, this is 3 by 10. We will just multiply them. This will become 21 by 100. In third part, this word is given that, while in fourth part this is and. This is probability of g intersection y. This is given by probability of g into probability of y. 7 by 10 into 3 by 10, that is 21 by 100 here. In case of with replacement, again this will be the product, but now you have the probability from tree diagram g and y. Probability of green is 7 by 10, then probability of y is 3 by 9. This will become 7 by 10 into 3 by 9. This is equal to 1 by 3, 7 by 30. So this is 7 by 30 here. 7 by 30. The second marble drawn is yellow in both cases. Now in this part, there is no condition on the color in the first draw. So when you say the second marble is y, the first marble could be green or yellow both, because this is not condition that the first color should be green or yellow. It is only given that the second marble should be yellow in both cases. Both cases mean in case of with replacement and case of without replacement. If the first is green and then second is yellow, this is given by 7 by 10 into 3 by 10 from tree diagram. And this is yellow and yellow, and this can be seen from tree diagram in case of with replacement. This branch can be used here. Yellow in the first drawn, this is yellow, and the second drawn is also yellow. This is 3 by 10 into 3 by 10. So this becomes 3 by 10 into 3 by 10, this is 9 by 100, and that is simply equal to 3 by 10 after cancellation. In case of without replacement, second marble should be yellow. The first marble will be either it is green or it is yellow. The same concept we will use here, but probability will be changed here. In case of without replacement, the probability of green will be 7 by 10, and probability of yellow is 3 by 9. Gy. First is green, second is yellow. Without replacement, first is green, 7 by 10, second is yellow, 3 by 9. So this is equal to 7 by 9 into 3 by 10. This is equal to 7 over 30. And the second branch is yellow and yellow. 3 by 10 and 2 by 9 plus 3 by 10 into 2 by 9. This is equal to 6, 2, 5 is 10. This is 3 by 45, and again this is 1 by 15. So after the simplification, this is our answer: 3 by 10, 2 by 9, 6 by 90. This is also 6 by 90. Take LCM. This gives 3 over 10. One marble is green and other is yellow. In both cases, with or without replacement. One marble is green and other is yellow. This can be done in two cases. When you say one marble is green, so green will be at first place and yellow is at second place, or yellow is first place and green is at second place. So we will find these probabilities from tree diagram and we will add them. Uh, you will see both of the probabilities will be same. Either it is green to yellow or yellow to green. This is 7 by 10, 3 by 10, 3 by 10, 7 by 10. This is 2 times 21 by 100, that is 21 over 50. You can see from this, from T diagram. One is green and other is yellow. So you can move it as G to Y plus Y to G. Both of the probabilities will be same. If you move from G to Y, this is 7 by 10 to 3 by 10. 7 by 10 into 3 by 10. This is equal to 21 by 100. If you move from Y to G, this is 3 by 10, 7 by 10. Again, this is 21 by 100. So that's why probabilities are same. And you will add both of the probability. This will become 2 into 21 by 100, that is 21 over 50. While in case of without replacement, probability of G to Y, this is 7 by 10, this is 3 by 9. 7 by 10 into 3 by 9 plus Y to G, probability of Y to G. This is 3 by 10, this is 7 by 9. Again, same, 3 by 10 into 7 by 9, because they are same, because their denominators are same and nominator is also same. So that's why it will again 21 by 90 here. So it becomes 2 times 21 by 90, that is 21 by 45 or 7 by 15 here. Problem number 8. This problem is actually not related to dependent and independent events. Actually, this problem is related to addition law of probability. This is related to A union B. But this is also an important problem. This problem says there are 25 boys and 15 girls in a class. 12 of the boys and 5 of the girls have blue eyes and remaining have brown eyes. One boy and a girl are selected at a random. What is the probability that both have a blue eyes? What is the probability that both have a brown eyes? If only one person is selected at a random, what is the probability that she is a girl or has a brown eyes? Following table summarize the given information. This is given information. Boys, girls, eyes, blue, brown. Total boys are 12. Total boys are girls. Sorry, total boys are 25 and total girls are 15. 12 boys are blue eyes and 5 girls has blue eyes. So remaining has a brown eyes. So this there are 13 boys having brown eyes and 10 girls has brown eyes. From both sides total should be 40. These are 12 plus 5, total 17 blue eyes person and total persons of brown eyes are 23. 17 plus 23, this is 40, and 25 plus 15, these are also 40. We have to find a probability of a boy having blue eyes. We have to find the probability in the first case. One boy and a girl are selected at random. What is the probability that both have blue eyes? Both have blue eyes. Probability of a boy have blue eyes. As there are total boys total boys are 25 and the boys that have a blue eyes are 12. So this is the 12 over 25. A girl have a blue eyes. Total girls are 15 and the out of these 15, 5 girls have the blue eyes. This is 5 over 15, that is 1 by 3. Given events are independent in this first part. Boys and girls both have a blue eyes. Boys, what is the probability that boy and girl both have a blue eyes? So this is equal to simply their multiplication, that is 12 over 25 into 1 by 3. That is 4 over 25 here. Next we have to find the probability of a boy and a girl both have a brown eyes. Probability of a boy having brown eyes. There are 13 boys that have brown eyes out of 25. So this is 13 over 25. Similarly, a girl having brown eyes, these are 10 out of 15. That is 2 by 3 here. So probability of boy and a girl both have brown eyes are, these are the independent events, because if a girl has a brown eyes, it will not affect on the probability on a boy have a brown eyes. So these are the independent events. So this is 13 by 25 into 2 by 3, that is 26 by 75. Here the important fact is that here to calculate probability of brown eyes, we cannot use law of complement. That is, if we are interested to find a probability of a boy and a girl both have a brown eyes, this cannot be done by simply taking complement 1 minus probability of boy and girl both have a blue eyes. Why? Because here note both have a blue. When we say both persons not have a blue, it means at least one is not blue. Both not blue mean first one is not blue, second one is not blue. It means at least this is possible that at least one is not blue. That include blue boy, brown girls, brown eyes boy, blue eyes girl, brown eyes boy and brown eyes girls. So 1 minus probability of boy and girl both have blue eyes does not give both brown eyes. What is the second part? In the second part, if only one person is selected at a random, what is the probability she is a girl or this is the union or has a brown eyes? Let G stand for girl and BR stand for brown. So we have to find probability of G union BR. This is simply equal to probability of G, probability of BR minus probability of their intersection. What is the probability of girl? There are total 40 students and out of these 40 there are 15 girls. Brown eyes. There are total 40 students and out of these 40 there are 23 students who have brown eyes. From the table you can observe that this row represents the candidates who have brown eyes. So these are the 23 out of 40. Similarly, from the table you can see there are how many girls that have a brown eyes. These are 10. Yes, these are 10 girls that have a brown eyes. So this is the number in the intersection of girls and brown eyes. So this becomes 28 by 40, that is 7 by 10. You can calculate this it alternatively. When you have to find probability, it is either girl or brown eyes. It is simply complement of it should be boy with blue eyes. What is the opposite of girl? This should be boy. What is the opposite of brown? This should be blue eyes. So if we find probability of boys with blue eyes, there are 12 boys with blue eyes. From the table you can see there are this number. This is 12 boys with blue eyes. Now subtracting 12 over 40 from 1, this gives same 28 by 47 by 1. So the alternative method is very interesting. Next, a pair of die is rolled twice. It means total outcome will be 6 into 6, that is 36, because the outcome on a single die, you know, there are 6 outcomes. So pair of die means 6 by 6 by 6 into 6. What is the probability of getting a total of 7 on the first row and a total of 11 on a second row? And mean intersection. Now you have to decide whether the events are dependent or independent. Let A denote the events getting a total of 7 on the first row and B even getting a total of 11 on the second row. How can we make 7? From 2 dice we can make the 7 by using the following pairs. 1, 6, mean to say there is a 1 on first die and there is a 6 on second die. Total will be 7. 2, 7, 3, 4, 4, 3. These are the possible total outcomes, that is equal to 6. So probability of A is equal to 6 by 36, that is 1 by 6. This is the probability to getting 7, sum 7. To getting 11, there are the only 2 possible outcomes, 5, 6 and 6, 5. This is 2 outcomes. Out of 36, this is 1 by 8. Since given events are independent, because there is no relation, when you get 7 on 2 dice, it will not affect that your sum is 11 on the same 2 dice. So we will use simple law of multiplication, that is probability of A intersection B is probability of A into probability of B. What is probability of A? This is 1 by 6, probability of A B is 1 by 18, that is 1 over 108. Very simple. This is also very interesting problem related to independent events. The probability that A will alive 10 years is 5 by 7. B will be alive after 10 years, this is 7 by 9. Find the probability that both of them will die. Both of them will be die. Let A and B denote the event A alive, B alive. A mean the person A alive and B mean the person B alive after 10 years. Then A complement, B complement denote A dead, B dead respectively. So here probability of A, this is given 5 over 7. Probability of B, this is 7 by 9. This is given in the information. A will alive, this is probability 5 over 7. B will alive, this is 7 by 9. Probability of dead, A will dead. This is probability of A complement, that is 1 minus probability of A, 1 minus 5 over 7, this is 2 by 7. B will dead. This is probability of B complement, 1 minus probability of B, this is 2 by 9. We have to find probability both will die. Both will die mean neither A alive nor B, that is probability of A complement intersection B complement. Probability of A complement, probability of B intersection will be changed to multiplication because these events are independent. If A die, then it will not affect on the life of B. So these are the independent events. So this becomes probability of A complement into probability of B complement, 2 by 7, 2 by 9, that is 4 over 63. A will be alive and B dead. Again, the events are independent because life of A does not affect the life of B. Similarly, if A die, then we cannot say B will die. So probability of A will alive and B will dead is given by probability of A intersection B complement, that is probability of A into probability of B dash. Probability of A is 5 by 7, probability of B dash is 2 by 9, 10 by 63. B will be alive and A will be dead. This is B, probability of B intersection A complement, that is probability of A into probability of B into probability of A dash. This is simply after multiplication 2 by 9. Both will be alive after 10 years. That is probability of A intersection B. Probability of A into probability of B, 5 by 7, 7 by 9, 5 by 9. At least one of them will be alive after 10 years. At least one of them will be alive mean either A alive or B alive or both will be alive. If A alive, it is represented by A intersection B complement. A alive means B dead. B alive, it means A dead. Both alive, probability of intersection B. Probability of intersection B complement we have found this is 10 by 63, this is 14 by 63, and probability of intersection B is 35 by 63. After simplification, this gives 59 by 63. Almost one of them will be alive after 10 years. Almost one of them will be alive mean either A alive or B alive or none of them alive. Almost mean maximum. Maximum one of them alive. So A alive mean A intersection B complement. B alive, this is A complement intersection B. None of them alive. A complement intersection B complement. After putting the answer, this gives 28 over 63. Okay, next we discuss after prayer. I hope you are enjoying from this lecture. Welcome back. I hope you are enjoying this lecture very well. If you are finding this lecture helpful, please like, share, and subscribe my channel. We are left with four more problems, and then we close this lecture. And these four problems are very important. I guarantee that if you completely understand this lecture, you will be able to fight with every probability questions that can ask in your O-level mathematics exam. So let us start. This is problem number 11. A bag contain 8 red, 5 white, and 7 black balls. If 3 balls are drawn, find the probability that the that they are drawn in order. First is red, second is white, and third is black. If each ball is replaced and not replaced before selecting the next. Mean to say we have to find the probability in both case, in case of with replacement and in case of without replacement. Firstly, we find the probability in case of with replacement. Total red ball are 8, total white are 5, and total black are 7. This gives total 20 balls. We need to find the probability of red and white and black. I think this is black. Yes, black. Because the word is and, it means we have to find the intersection. And this is the case of independent events. So the probability in case of intersection is converted to product. And it is not possible that two of the ball have both color red, white, white, black. Each ball has a single color. So there is no case of intersection of two colors. Now probability of red is 8 out of 20, probability of white is 5 out of 20, and probability of black is 7 out of 20. So this gives after cancellation 7 over 200. In case of without replacement, this is interesting, and this problem suggests that we can use the case of independent events, case of intersection for two or more than two events. Okay, first ball is red. Now order is matter here. First ball is red. There are total 8 red ball out of 20. When you have picked one ball and you are not allowed to replace the ball now. Now total balls remaining are 19, and next ball is white. So probability of white will be now 5 over 19. So this is 5 over 19 here. The third ball is black. Now we have remaining 18 balls and black balls are 7. So this is the order in which we will write the product. 8 over 20, 5 over 19, 7 over 18. Suppose if we have order red intersection black intersection white, now you can observe that answer will be changed here. So answer will be, I think this will be same because this is the product and the denominator will be same here. So answer will be 7 over 171 again. This is the problem number 12, and I have specifically write it probability of combined event, they are dependent. Uh, in this problem, there is a no clue. There is a no specifically mentioned that the problem belong to dependent event. You have to judge by yourself. It is given that out of 33 students in a class, 21 students study geography, 12 students study history, none of the students study both subjects. So there is no intersection here. Two students are selected at a random from the class. Draw a T diagram to show the probability of the possible outcomes. Clearly, it is clear from the question that when you select one student from the class and you ask him uh, which subjects which subject do you read. Suppose he say he study geography. Now you will not send back it. No, you will not send him back to the class. So next you choose when you next choose the second students. Now you have 32 students remaining. So that's why these are the dependent events. In case of dependent events, at every second or third draw, the total students become reduced and probability at each draw will be changed. Next we make tree diagram. This is your first student. Either he reads geography or history. If he reads geography, total students are 21 out of 33. Its probability is 7 over 11. If he read history, total students who reads history are 12 out of 33. So their probability is 4 over 11. Now when you pick second students, one students you already have selected. Now remaining students are 32. Now again you have two choices. Either he reads geography or history. If he reads geography, then now total students who can read geography are 20 because one student who read geography is already chosen at first place. So now remaining students who read geography are 20 out of 32, that is 5 over 8. This is student of history. At this branch is for geography students. So for this branch I have not chosen a student who reads history. So students who read history are 12, but the total is changed, that is 32. So at this branch, probability of history student is 3 by 8. Again, now I have two choices from this branch. Either this second student can read geography or history. If he reads geography, this is the branch of history. So total geography students will be same, that is 21, but out of 32 because one student of history is chosen already from here. And if I choose this student is history, so total students will be 32 and one student will be dropped from here, that is now total students of history will be 11. So the probability is 11 over 32 here. Albert said that the probability that both students study history is 16 over 121. Explain what he has done incorrectly. Albert actually calculated the probability by taking the product 12 over 33 into 12 over 30, which gives 16 over 121. The mistake that he is doing, he did not take into account that there are only 11 history students and 32 total students left after the first student was selected. So the correct answer should be if both students study history. The correct answer will be at the first place, students who read history. This is 12 over 33. That is 4 by 11. The second student also read history. This is 11 over 32. So the correct answer will be 1 by 8. This is the correct answer. Find the probability that the first student study history and this is important and the second student study geography. In case of and, we will need to find the probability of intersection. The first student read history mean H and the second student read geography H intersection G. So it is denoted by probability of HG. First student read history. From the tree diagram, the student who read history and second read geography. History, geography. We will use this branch, history and geography. Student who read history, this is 4 by 11 and geography 21 by 32. So this is the product and this product is equal to 21 by 32. This is equal to 21 over 88. Suppose in this question it is given that find the probability that the first student studies history given the second student study geography. So then in this case I will not find the intersection. This can be done in the similar way as I discussed in above questions. In B, third B, one student study history while the other student studies geography. Now I have two possibilities. One student studies history and the other one study geography. I have two possibilities. Either first student read history and second is of geography, or either first student is of geography or second student is of history. Either or. In case of or, we will use always here plus sign. So what is the probability of HG, history and geography? This is 4 by 11, 21 by 32. You can check it from tree diagram. First geography, then history. This is 7 by 11, 3 by 8. After multiplying the both, this is 21 by 88, 21 by 88, that is 21 by 44. This is very important problem, and I hope you will enjoy, you will like this problem very well, because I think this problem is very close to the nature of O-level students. A box contains n marbles. 8 of the marbles are blue and the rest are red. Ken takes 2 marbles from the box at random without replacement. Complete the tree diagram. We are given a tree diagram. We have to complete this. At the first row, we have a two color, blue and red. So the probability of blue is 8 by n, and we have to complete this tree diagram. Okay. We have a blue. 8 marbles are blue. This is marble or balls. These are the marbles. Okay. There are 8 blue marbles. Total are n. So the remaining are red. Remaining will be total minus blue. This is n minus 8. So this is n minus 8. N minus 8 are red marbles. Probability of red marble will be n minus 8 out of n. This is n minus 8 over n. Probability of red at second row. Next we have to find we have to complete this. At a first draw we have two color blue, either blue or red. Probability of blue is given. Now probability of red, I think I have to write here. This is blue are 8, red are n minus 8, total are n. Okay, now we have to calculate the probability at first place for red. Total marbles are red, n, and red are n minus 8. So this is the n minus 8. Now for this is second draw, and in the question it is given that we have to choose the marble by without replacement. It means at the second draw marble will be n minus 1, because total marble are n. At the second draw marble will be n minus 1. Okay, this is red. From this branch we have not chosen any red, because this is the branch of blue. So the total red will be same, that is n minus 8, but total marbles are n minus 1. So this is n minus 8 over n minus 1. Now we fill this. This is the branch of red. So total blue are 8, but this is the second draw. So marble will be n minus 1. So this is 8 over n minus 1. Red. This is the second draw, and this is branch from red. I have already choose one red from here. Now the remaining red will be n minus 8 minus 1, that is n minus 9. This is n minus 9 out of total marble are at second place n minus 1. So this is the tree diagram that you can fill this by this. The probability that can takes two blue marbles is 4 over 13. This is very interesting question. This is very interesting part. It is given that two blue marbles has the probability 4 over 13. Write down an equation to represent this information and show that it simplifies to the quadratic equation n square minus n minus 182 equal to 0. From the tree diagram, because we have two blue marbles at both places. So if you check from tree diagrams, we will use this branch for both blue marbles, this branch. At the first place this is 8 by n. At the second place it is 7 over n minus 1. So we will take this probability equal to the given probability. Given probability is 4 over 13. So by equating both of the probability, this is 4 to the 8, this is 2 7 the 14, 14 over n into n square minus n. By cross multiplication, this gives n square minus n into 13 into 14. 13 into 14, this is 182. This is the required equation. Solve the equation. Next part is solve the equation. This is the quadratic equation by middle term break method. This gives two factors, minus 14n plus 13n. So after simplification, this gives the two values of n. One is n is equal to minus 13 and one is n is equal to 14 here. Fourth part, explain why one of the solution in part number 3 must be rejected. In part number 3, we have found these two values of n. Now we have to reject one of the value. We must reject n is equal to minus 13 because here n shows number of marbles. Sorry, this is not a balls, these are marbles. So n shows number of marbles that cannot be negative, because number of marbles, number of balls, etc. always are positive integers. So it cannot be negative. So that's why we will reject n is equal to minus 13 here. Find as a fraction in its simplest form the probability that can takes one blue marble and one red marble. Probability of one blue and one red marble is given by either it is first is blue, second is red, or it is first is red, second is blue. So probability, if we move blue to red, then from the tree diagram, from blue to red, we will move towards this branch. Blue is 8 by n, and red has the probability at second place n minus 8 over n minus 1. So this is given by n 8 by n minus 8 over n minus. Similarly, if we move towards R to B, this is n minus 8 over n into 8 over n minus 1. As the valid value of n is 14, so put n is equal to 14 here. This is 8 over 14, 6 over 14. After putting n is equal to 14 here. So this gives the final product equal to 48 over 91. Okay. Next we are going to discuss the last problem of today lecture, and this is also very interesting, and you can find this problem in your past paper. The diagram below shows two discs, each with 4 equal sectors. Each disc has a spinning pointer, which when spun is equally likely to come to rest. It means the probability of spinning the span is have a same chances, equally likely, in any of the 4 equal sector. Mean to say, pointer can stop at any sector, have equal chance of stopping. In a game, the players spin each pointer once. His score is the sum of the numbers shown by the pointer. This is first disc that has a 4 number 10, 20, 20, 30. Second disc, these are the 4 number 0, 30, 30, 30. In the first part, it is given that following table shows sample space of 2 discs. By spinning their pointer with their sum, complete the table. Okay. This table is given. This is our first disk and this is second disk. This is the score on the first disk and this score is given by the second disk. This first row is calculated as by adding 10 into 10 plus 0, this is 10, 10 plus 30, this is 40, 10 plus 30, 40, 40. We have to find these remaining 9 values. 3, 4, 12 values, sorry. This is simply given by adding elements 20 plus 0, this is 20, 20 plus 30, this is 50, 20 plus 30, this is 50, 20 plus 30, this is 50. Similarly, you can add 30 plus 0, 30, 30 plus 30, 60, 60, 60. So this is 4 by 4 table has a 16 values total. Calculate the probability that the first number obtained in the pair of sample space is less than or equal to the second number obtained. For your convenience, let K be the event that shows first number is less than or equal to second number. So the possible K's are, from the sample space, you can check that only the pair in which first number is, we have to find the first number is always less than or equal to second number. The sample space in which the first number is greater than the second number. These are four possible outcomes: 10 0, 20 0, 20 0 again, 30 0. These are the 4 possible outcomes that are actually combination of these numbers with 0. In these 4 pairs, you can notice that first number is greater than 0. It means other than these 4, remaining 12 outcomes has the property the first number is always less than or equal to the second number. For example, if you notice 10 30, 10 is less than 30. Similarly, 20 30 is less than 30. 13 30, this is less than or equal to 30. So the possible outcomes, these are 12. These 12 pairs in which first number is less than or equal to second number. So number of k are 12. Now we have to find the probability. Probability is simply given by nk over ns. Total sample space has the number 16. This is 12 over 16. This is 3 by 4. Next we have to find the probability. The second number obtained is 0. Let j represent the event that second number obtained is 0. This is given by 10 0, 20 0, 20 0, 30 0. These are 4. So the intersection is 1 by, probability is 1 by 4. If the player score is between 10 and 40, he received $2. If his score is more than 40, he received $5. What is the probability that he received $2? He receives $2 if sum of score is between 10 and 40. So possible scores are 20 and 30. Here it may be noticed that between 10 and 40 mean endpoints are not included. So the possible scores between minimum score is 10 and the maximum score is 60. For $2, score will be between 10 and 40. So from this diagram, from this table, you can notice that the scores between 10 and 40 are 20 and 30. These are the possible scores. Now you have to count how many outcomes have 20 and 30 sum. So these are given by these are the three outcomes from table. You can notice that in which score is 20 and 30. So this is 3 out of 16. Probability of 5. He will receive $5 if sum of score is greater than 40. A score greater than 40 is either it is 50 or 60. It is given by the possible outcomes. 20 and 30, this gives sum 50. It is 6 times in the table. And the other score is 30 and 30, this gives 60. This is given 3 times in table. So total outcome, favorable outcome are 9 out of 16. So this is the this probability is 9 over 16. Probability of $2 or 5. This is probability of union, and in case of union, we will use probability of mutually exclusive events because there is no intersection. Either he will receive $2 or $5. So probability of $2 plus probability of $5. This is 3 over 16 plus 9 over 16. That gives 3 by 4. And it completes our lecture. And I hope I have done my best to deliver this lecture. If you find this lecture helpful, please like, share, and subscribe my channel. Further, if you want to get these PDF notes, you can comment me or you can drop your message at this number, that is 315-1648755. And further, if you are interested in personal tutoring, you can also WhatsApp me. This number is also available for WhatsApp. Okay, take care. Allah Hafiz. See you in the next lecture. In the next lecture, we will discuss all past previous year questions of probability and combined events from paper 2025 to 2020, inshallah.